This is one of those problems where it looks simple from the picture, which is how I pick the problems out, but when you actually go to solve it, it's quite complicated. So we're given here the boy trying to kick a ball over a 3-meter high fence 6 meters away. And so it's a pretty standard projectile motion problem. AX is 0, and acceleration of y is due to gravity minus g. We know the initial velocities in the x and y direction are just going to be the x component and the y component of the initial velocity. So that comes out to v0 cos theta and v0 sine theta for v0x and v0y respectively. And so then we're taking the coordinate system starting where the boy is kicking the ball, so the initial x and y are both 0. And so starting with the standard formulae for projectile motion, x0 plus v0 xt, y0 plus v0 yt minus 1/2 gt squared. Putting in that x0 and y0 is 0, and then v0x and v0y are v cos theta and v sin theta, you get these equations of motion. Well, at the point the ball is going over the fence, the x is equal to d, and the height is equal to h, so we get these two equations right here. But if you look at that carefully, there are 3 unknowns: v0, theta 0, and the time. And so this is what's happening. There are actually an infinite number of v0 and theta 0s that will clear the fence just over the fence, so I've drawn 4 of them in here. So what we want to do is find the one with the minimum velocity. So v0 is a function of theta, okay? You see the 4 lines I drew there. And so we want the line that represents the minimum v0. So what we have to do, and this is what makes the problem hard, we have to get the initial velocity as a function of the initial angle to just clear 6 feet, 6 meter, 3 meters. And then we're going to have to get the minimum velocity as a function of theta. So that means taking dv d theta equals 0 and then solve for the theta that minimizes that and then plugging it back in. Okay, so here are our 2 equations, and what we need to do is make that as a function of v in terms of theta, which means getting rid of the t. So you solve one for t, and then you put that back into 2, and then you get this kind of ugly equation. Well, the v0 cancels out in that first term, and then it turns down into this. But remember, we're looking for a function of v0, so you go through all this algebra, and then you finally get that v0 is a function of theta, like this. Okay, we're going to have to take the derivative of that with respect to theta and set it equal to 0. And so I just replace square root g over 2 times d as c1. So there you go. So to make the derivative a little easier, I'm going to write it like this, and then take the derivative of that. So here we go. I started, and I gave up. I didn't want to do that derivative, plus we're going to have to set that equal to 0. That was going to be a nightmare. So I looked in the solution manual to see how they did the calculus, and we're going to try something else. So first off, I want to simplify that denominator. And so cos theta times the root of d tan theta minus h. I'm going to put the cos theta under the square root as a cos squared. And so you end up with this right here. Okay. And then starting here, I'm actually going to do something a little different than the solution manual. So we get that the function is this, and it simplifies to this, where the function of theta is that d sine theta cos theta minus h cos squared theta. And so I actually got this hint from the solution manual as well. V of theta will be a maximum when the denominator will be a minimum when the denominator is a maximum. And so if we can find when the denominator is maximum, we'll get V minimum. So this now boils down to finding the maximum of f of theta. So I'm taking d theta, and again, f of theta is everything under this square root sign here. So we need to find the derivative of this and set it equal to 0. That's not bad. So the derivative of sine cosine is cosine theta times sine theta plus sine theta times minus sine theta using the product rule. And then using the chain rule, the derivative of cos squared is 2 cos times the derivative of cos, which is minus sine theta. And so you set that all equal to 0, and it's still not looking good. But cos squared minus sine squared and 2 cos and sine, 2 cosine are both functions of cos and sine 2 theta, if you remember your double angle formulae. So cos 2 theta happens to be cos squared minus sine squared, and sine 2 theta is 2 cos sine, so right there. So it ends up being d times cos 2 theta plus h times sine 2 theta equals 0. We can easily solve for that. Divide the equations, put it on the other side, so you get tangent 2 theta is minus d over h. You can solve for theta on your calculator, and then plug that back into the equation for v as a function of theta right here, which I've rewritten here, and there you go. You can get the answer. Now, how I remembered the 2 theta formulae, this is a bonus. If you happen to know complex variables, which many of you don't, we call the square root of I, square root of minus 1, we call that I. It's imaginary, right? It doesn't exist. And so if you use the Taylor series for e to the x, but you say e to the I theta, and remember that I is square root of minus 1, I squared, which would be minus 1, I cubed is minus I, etc. And you collect everything that doesn't have an I in it and collect everything that does have an I. I don't know if you've ever noticed that, but Taylor series for e to the x, cos x, and sin x are very, very similar. You get that e to the I theta is cos theta plus I sine theta, and that's kind of easy to remember. If you think of x is cosine theta and y is sine theta on a circle of radius 1, and I represents the y coordinate and the real is the x coordinate. So anyway, if you take e to the 2I theta, just by definition is cos 2 theta plus sine 2 theta. Well, e to the 2I theta is also e to the I theta squared, so you get cos theta plus I sine theta squared. And then if you use FOIL first, outside, inside, last, and you remember that I squared is minus 1. If you multiply out cos theta plus I sine theta squared, you get cos squared minus sine squared plus I 2 sine theta cos theta. And so then if you set this equal to that, and you match the real terms and imaginary terms, you can see that cos theta is cos squared minus sine squared, and you can see sine 2 theta is 2 sine cosine. So there you go.